Hello and happy Tuesday evening. I wanted to record a quick video today on a topic that's very near and dear to my heart, and that would be colors, obviously. And the reason I wanted to talk about color was because it was sort of I don't know, the starting point for how I thought about same wavelength. I've been very interested in how color is this topic that's so pervasive in our culture and it determines so many things. And it's something that I've been interested in and have studied for so long in different fields. So, briefly, I want to talk about sort of how I think about color and how I got into studying color. And then I'd like to talk about what it has to do with this project, Same Wavelength. When I was a kid, I loved colors. I loved drawing. I loved painting. When I got my first big box of Crayola crayons, it felt like an epiphany. And I have so many memories of my different relatives coloring with me. My mom, when I was a kid, had to have me do my art homework last because if I started with it, I would just do like 3 or 4 hours of art homework and never get to anything else. And so I sort of came to view drawing as this real treat. And I don't know if the people who are watching this, if you all have any sort of conception of the divide between line and color in art, but there's this very ancient debate on what's more important in art, the line drawing shapes of things or the colors that make those things up. And I'll talk about that in another video because it's something I find super interesting as someone who's both very interested in like clean line drawings, as you've been able to see from the frog work that I was doing, but also color, also, as you can tell from my frog work and my wardrobe. But I sort of have always been really interested in color. My brother is partially colorblind. So when I was a kid, I was very interested in like the science of color and color perception. I remember when my brother was little, he did this science experiment on like how dogs perceive color. And my parents, he like basically it had something to do with like different colored like vessels and like dog treats, and I'll have to look it up at some point. But these questions have always sort of been bubbling in my mind, you know. There's the age-old question of like, if I see something that's a shade of red, how do I know that someone else sees it the exact same way? And especially for those of us who have red-green color blindness, I know that they don't. And so I think that's super interesting. And so because I was primed to think about this my entire life. It's no surprise that when I went to college and I ended up studying in a bunch of different fields, each one of those was touched by color, literally and figuratively, um, as we are all touched by light. But basically, I want to um, sort of explore what this means. I'm being very vague. Um, Color, in technical terms, is how someone or something perceives different wavelengths of light. And that's an oversimplification, and there's huge debate on that. But that's like an easy sort of understanding of like what color is and how much color has to do with perception. In philosophy, color is considered a qualia, so something like pain or a smell. It's a sensation that's a subjective individual experience that chemical aspects or light aspects in the world can be analyzed, but the feeling of it, the perception of it is unique to the individual. There has to be a receptor, whether that receptor is conscious or not. Already you can tell we're getting into like very deep and murky territory, which is where I thrive. So the four fields that I was studying in college were physics, philosophy, neuroscience, and art. All four of those have been completely and utterly touched by the concept of color. So for physics, it's sort of obvious. One of the realms of physics is the study of light. Light is a very important concept for physics, both because the cosmic speed limit is the speed of light, and also because, the entire field of optics is about light, which is interesting because optics, you think about like the eye, But light is this thing that one would suppose exists with or without someone perceiving it. Um, and that again, that gets into whole territories that break wide open. You talk about uncertainty, you talk about the wave particle duality of light, you talk about photons, you talk about light waves, all of these things. And this is not the video for that. But um, obviously physics, super involved with light. When I was young, I learned about Isaac Newton's experiments with light. I think sort of everyone learns about the prism, whether you're into Pink Floyd or not. Um, the famous experiment of white light coming into a prism, splitting into the colors, and then being redirected through a prism and then turning back into a single beam of white light. Um, there's a ton to discuss about um, just what the actual spectrum of visible light is. Is it different for different people? I could tell you, and I will tell you, a bunch of different facts about light perception when we get more into neuroscience, which is the next field I wanted to talk about. Um, Neuroscience is really interesting because it's both involved with the brain itself and brain studies, and also, of course, all the other organs and sensory um, receptors in the body, because it has to be. The brain is responding not just to what's going on inside our heads, but also to the ways in which our bodies are reacting to the environment around us. So obviously, the nervous system isn't just the brain, it's the brain, spinal cord, the nerves. It's everything. That might be wrong. I didn't go to medical school. But what is true is that the brain is analyzing data from our experiences. And so um, an individual's perception of light is, uh, God, it's tied to so many different things. Um, in the broad sense, there's so many different experiments about light perception, of how our eyes adapt to light, how, if you cover one eye and expose it to a different shade of light, it automatically becomes adapted, so that we like don't even notice it anymore. You can test this out by like getting a pair of sunglasses that's really purple, and then after a while, you won't even realize that you're being inundated with purple light because your eyes have already made that adaptation. That's like a sensory thing in the brain. Again, there's a lot of communication between the eye and the brain. There's a lot of really interesting studies about when someone has a vision problem, whether the vision problem is in the eye itself, in um, deeper back in the ocular nerve, or in the brain itself, or somewhere in between. And that's super fascinating. You can learn all sorts of things about, I think it's the occipital lobe in the back of your head is where vision is. It's been a really long time since I've taken a neuroscience class, which is kind of embarrassing given that I'm trying to be an educator on YouTube. But anyways, there's all of these things that are super absolutely fascinating in neuroscience, just about light, just about that one simple topic. Um, and that brings me to philosophy, my bread and butter, where I spent a lot of classes talking about questions like, if a tree falls in the forest and no one's there to hear it, does it make a sound? And there's some like people who really think like if there's no people around, if no one had eyeballs, there wouldn't be color. And that's and like real people believe that's like a real theory that I don't want to say like most scientists would agree on, but like it is true that the way in which we perceive different wavelengths of color is not, it has something to do with the wavelengths that are out there, but it also has a lot to do with our the way our brains work and the way our eyes work. And I'll talk a little bit more about that in a minute. Um, but that's super fascinating. And so, unfortunately for me, my biggest gripe about school was that often the physicists weren't talking to the scientists and the scientists weren't talking to the physicists. And so I had all these existential, fascinating philosophy questions that really could have only been solved in the sciences. And similarly, science, can butt up against a wall, and then you start asking philosophical questions because you don't necessarily have the means to test certain things up at that point. And so this is the wonderful realm of thought that I raised myself in. And I've always been fascinated by these things. I like found a notepad that I had written questions on when I was a kid, and I'd written things like, if you have two cans of paint that are almost identical in chemical structure, why is one really vibrantly red and why is one really vibrantly, blue? Similarly, if I have uh, why do vinegar and coffee look the same? All of these different things that like as soon as I learned more about chemistry and atomic structure, they made sense. But it's still really fascinating. And I still have a lot of questions about how certain chemicals elicit different color properties. I am moving into art, not a paint maker. I did that once and it wasn't great. Ground up some roses and tried to make paint, which also is really fascinating because sometimes you learn that when you grind up something, you would think, oh, well, this is one stone or one flower or whatever. It should be the same thing if I'm grinding it up, but it'll completely change color. Lapis lazuli is one of those examples where it's a really vibrant blue, and the more you grind it, the more its color changes a little bit, which is fascinating. Actually, a lot of stones are like that, malachite, et cetera, et cetera. I'll get a pigment expert on here soon. But anyways, these are fascinating questions that have to do with sort of chemical and atomic structure, which are really fascinating. And if you're not a paint user like I am, or you're not, mixing nail polish colors, you're not really going to be thinking really critically about a lot of these things. And sort of, unfortunately, the last time a lot of us think about art and mixing colors is childhood. Um, all that is to say, color is a field that touches a lot of really interesting fields. And unfortunately, one of the things that I was thinking very deeply about as a graphic designer was that I personally am so entrenched in color and thinking about color, and every piece of work I ever make is going to be completely accessible to anyone who's blind. And I learned a lot about accessibility when I was a physics student. Ironically enough, I learned graphic design things when I was in a completely different field. But when we were doing our presentations, we had to make a poster, and we had someone come in who said, be very careful what colors you choose to use on different bars and graphs and things, because, something like 1 out of 8 or 1 out of 10 or 1 out of 12, I'll look it up, men have red-green color blindness, and so it's difficult for them to see um, different shades and hues of red and green and certain colors in between. And that really struck me because I was thinking about how much regular graphic design is inaccessible to someone who still has vision, but has it not impaired, but like changed in this certain way. And how it's really wonderful that we know that and that we know enough that we can like shift the way we design things for those people. Um, but it did make me really sad that this wonderful thing that I'm involved in and interested in is inaccessible to people who have no vision whatsoever. So when I came up with the name Same Wavelength, my initial thought was, oh, the connection between the arts and the sciences is color. That's so obvious. And then I realized that's kind of a garbage thing to do if there's like a bunch of people who won't be able to be interested in it or access it. And then I realized that waves are this more universal and enduring aspect of the universe. So you have uh, waves in water, you have earthquake waves, you have sound waves, you have all of these other kinds of waves that compose our existence. You have uh, certain quantum physics uh, formula that can turn any massive object with mass object into a wave. Um, and that sort of made me rethink what I was interested in and sort of the massive connection, massive, between arts and sciences, in that, I have a lot of friends who aren't art painters, artists, but they are musicians, and all of music is waves. It's a symphony and a, you know, explosion of different waves coming together to create a perceptual reality that's different for each and every one of us. And I think that's beautiful. So that's sort of where the name Same Wavelength came from and the process I went through while considering whether to keep it or not. Um, and yeah, I do still want to throw out a couple color facts because again, I love this stuff. It's what I'm interested in. I if we could get to a place where like people who are blind who would like to see are able to more and more be able to see due to technology. Or you have, I know some company or several companies make glasses for people who have color blindness to see correctly. Again, that's not necessarily what I believe, but like see the world in a way in which like I see the world, for example, or the average person sees the world. I think that's really wonderful. So I'm gonna give some of my favorite color facts. One I learned absolutely recently, while I was doing research for this channel and also just in my typical scrolling of the internet, has to do with this question I was asking myself, which was, what color is ultraviolet? And that might be an incredibly stupid question on the face of it, obviously, because ultraviolet exists outside our human range of visible light. There's infrared at one end and there's ultraviolet at the other, and both of those are invisible to us. But I was asking myself whether ultraviolet and infrared are, if we could see them, are they white? Are they clear, like invisible? Like, is it possible that every single wavelength of light slash energy has a corresponding color to some organism with visual organs that are tuned to that wavelength? Um, and I should have done more research about this, but what I did find out is that some ultraviolet does actually have colors, which is fascinating. And the reason we know that is because before modern cataract surgery, the old-timey cataract surgery of like, I want to say the late 1800s, early 1900s, left part of the eye exposed. And so our retina, I believe, part of our eye, the part of our eye that is photosensitive, that actually like responds to light, is actually capable of perceiving ultraviolet light in certain wavelengths. But the way in which our lens is crafted or has evolved makes it so that those wavelengths, which again are dangerous to people because UV light is dangerous to people, um, makes it so that those wavelengths don't come in. I don't know whether the lens was a later adaptation, which would, I guess, sort of make sense in the sense that, like, why do we have the perceptual ability to see UV if we're never going to be exposed to UV? Maybe some ancient humans or pre-humans could see ultraviolet colors, and then that was like so damaging to them that like we evolved towards eyes that don't register the colors of UV light. I have no idea. Would be a fascinating thing for people to research, or they already have, and I just don't know about it. And I would love to be educated. Um, but basically, we know about this because some people had this surgery that opened up part of their eyes more, and one of them was, I believe, Manet. Let me make sure that it was. That's like a big enough issue that I actually want. I think it's Monet. It's Monet. Um, and he basically was going blind or almost completely blind because of his um, cataracts, and his paintings were really muddy and terrible because he couldn't see anything. No offense to him, although he felt that way because when he had his vision mostly restored, he destroyed a bunch of his old work or corrected it. But anyways, during the time that his eyesight was restored, but that he was missing that part of his eye that blocked out UV rays, he did paint a lot more um, deeper and more saturated purples and was like clearly more drawn to them. And I think that's absolutely fascinating. I don't know whether that directly means that he could see deeper purples. Um, I don't know, but I think in the case in which we can actually perceive color in that part of the spectrum, that's really fascinating because that has a lot of really interesting implications for what um, the world is like just outside of the way we perceive it. And more on the UV stuff. Absolutely fascinating. Some flowers that look like they're just one color to us, like white or bright yellow or whatever, actually have spots and stripes and all sorts of patterns in the UV range that are only visible or are visible not to us, but to like bugs and birds. And the reason we know that is because we've photographed these plants in the UV spectrum, and we know those patterns are there, and we know that they must come from somewhere. And the sort of easiest explanation is that uh, they're looking for their pollinators, and their pollinators being birds and bugs. And I'm sure we've done studies on the eyes of birds and bugs, or the brains of them, and been able to see whether they can see um, UV, and that's pretty fascinating to me. It sort of puts the human primacy argument up to debate because it's like, it's really interesting that there are things about this world that we can't sense, not just because we have duller senses than other animals, but because we're literally not tuned to certain frequencies that the animals are. So in the same way that dog can hear a different frequency of sound than humans can, some of these animals can see different things than we can. And I think that's a little frightening but exciting because humans are such sight-based creatures that like the dog thing is interesting to us, but I don't think the average one of us cares that much. But the sight thing, the idea that there might be these secret messages out there in the universe that we can't read, is really interesting, at least to me personally. So those are two of my favorite facts. I think there's the one that a lot of people know is about mantis shrimp. Mantis shrimp have more cones than humans do, which are different light receiving cells in the eye. And some recent research indicates one thing I read at least says that like they their cones don't like I don't want to describe this incorrectly. This is now a pseudoscience channel. Um, one thing seemed to indicate that it's not that they have access to more shrimp colors than we do. It's just that the way their eyes or their brains mix color is differently. So they might have a similar perceptual spectrum to how to what we have, but it's just processed differently versus, oh my God, they have 17 different cones. What are they seeing? What are the shrimp colors? I think one of the like college application essays I had to do when I was a kid was like, what do the shrimp see? So I think that's all super interesting. I have a lot of questions on qualia. I have a lot of questions on whether when I perceive something, someone else perceives the same thing. Um, it gets into a lot of really interesting discussion on like, you know, if I hate a piece of art, does someone else hate a piece of art for the same reason? Or do they love it because they actually are seeing a different color and they like it more than I do? Um, and, the larger implication of this is like we should all be nicer to each other because we never know what we're going through or what we're all perceiving, yada yada. Um, all the good fun moralizing that I do on this channel about us being better people. But it is really absolutely fascinating to me how, yet again, one really seemingly small topic can bloom into something so big. I remember in high school, I was talking to one of my friends and I was like, oh, I love color. And he was like, that's so dumb. Like, it's such a childish, I mean, it was in good fun, but he was like, it's such a childish thing. Like, oh, I love color. And I was like, yeah, I can retain my childlike wonder. That's a great thing. And I think we should be asking more questions. And it's a shame that more people don't have a connection to art and drawing and paints after their children. So that's my 2 cents. A little bit of lore about the channel, a little bit of lore about me. And hopefully any of this was kind of interesting. I'm sure I got a lot of things wrong, but again, as an excuse, go out there and research on your own. And I hope you learned something interesting, and I'm really happy to talk about one of my absolute favorite things in the universe. Thanks so much.